Alright guys, here is the review, or one of the reviews for the homework and to get ready for the quadratics, or not the quadratics, the factoring test. So here we go. This is going to help with getting you prepared for the test. Here we go. Axis of symmetry. Here are some definitions that you guys need to make sure you understand. This is the line which cuts a parabola in half. And it's that x equals a number, right? And the number is actually in the vertex. So if the vertex is, say for example, 3, 4, your axis of symmetry is going to be x equals 3, your x value. Okay? Your zeros, x-intercept, roots, solution, y equals 0. That's your separate. These are what we're looking for, x-intercept, roots, and solution. Your minimum is your lowest point of a parabola. The maximum is the highest point of a parabola. Alright, so your minimum is your lowest, your maximum is your highest. The vertex is the highest or lowest point of a parabola. So here you've got your highest would be your maximum, your lowest would be your minimum, right? The parent quadratic function is y equals x squared. Alright? Basically that's saying when you have your basic parabola, which is going to look like that, this is the equation that they're looking for. Your x-intercept, again, your roots, your solution, your zeros. You see how this is going to be equal to this and this. Your roots are your solution, your zeros, your x-intercept. And all of these is where your y equals 0. Alright? Your y-intercept, that is your b value, where x equals 0. So it's basically where the line crosses the y-axis. But your b is what we're looking for. But you need to understand that's where it crosses the y-axis and when x is equal to 0. What's the formula for the area of a rectangle? The area of a rectangle is your length times your width. So know that when they're asking for the area, they're looking for two numbers that multiply to give you what they're given. Alright, list 5 numbers that have more than 2 factors and cannot be simplified into a square root. So for example, when we simplify the square root of 16, we know that can be simplified to 4. We also know that if we have the number like 20, that's going to be 4 times 5, which would be 2 times 2. That would equal 2 square root of 5. Because I can circle my 2's. So those would not be, that cannot be simplified. So I'm looking for numbers that, if they're in a square root, they would not be simplified. I'm going to let you guys figure that one out. But some examples would be 6. So if you had the square root of 6, you can't simplify that anymore. That is going to stay. The square root of 10. The square root of 10 is another one. That can't be simplified anymore. That just stays just the square root of 10. If you had the square root of 20, though, you would have to simplify that into 2 square root of 5. But I want numbers that are not prime numbers. Not prime numbers, because of course prime numbers can never be simplified in a square. So that would, of course, stay in the square root. I'm looking for kind of these random numbers. I'll give you a hint, like the square root of 15 could never be simplified. That type of a thing. All right. In a quadratic equation, here we have a quadratic equation. As the a value gets larger, whether it's positive or negative, the parabola is going to get more narrow. So in this situation, the a value is 6. It's getting larger than 1. It would be larger than this because in this situation our a equals 1. So it would be narrower than your y equals x squared value. In a quadratic equation where here, as a gets closer to 0, whether it's positive or negative, the parabola is going to get wider. Meaning, if you have 0.6, then that equation would be wider because our a is 1 here. It would be wider. So you have to look at your a value to determine, is it closer to 0? Even if this was negative 6x squared, it would still be narrower. And if this was negative 0.6, it would still be wider. All right. The slope of this. When you're looking for slope, you know you can always use y2 minus y1 over x2 minus x1. This would be my x. This would be my y. This would be my x. Oops. This would be my y. Make sure this is your group 1. This could be your group 2. It really doesn't matter just as long as you're consistent. X and y and x and y. So your y2 would be negative 3 minus negative 3. Your x2, negative 5 minus 9. Now you notice I put negative 3 minus a negative 3 because I have a negative 3 here minus another negative 3. But I only put 1 minus here because it's negative 5 minus a positive 9. Don't just start throwing your negatives left and right and center in there. Make sure that it is consistent with the formula. Because I'm literally putting in 9 and 9. And I'm putting in negative 3 for negative 3. Do you see that? Alright, so negative 3 minus a negative 3 is the same thing as plus a positive 3. So I get 0 on top, negative 14 on the bottom. Make sure you understand if 0 is on the top and you've got a number on the bottom, anytime 0 is on the top, your answer is going to be 0. This would be a horizontal line. This would look like this. Alright? This is where y is always equal to negative 3. That's a horizontal line. Alright, if we were to find the slope of, this would be my x1, y1, this would be my x2, this would be my y2. So you do negative 18 here minus positive 10, because it's a positive 10, divided by negative 4 here, minus a negative 6. So I'm going to do minus and then a negative 6 right here. I'm being very consistent with the formula. So negative 18 minus 10 gives me negative 28, divided by negative 4 minus a minus, that's going to give me a plus. So that would be a positive 2. A negative over a positive is going to give me a negative 14. That is your slope. Okay? So that would be your rise over your run. You know. Alright? There we go. What's the slope of this? Here's my x1, my y1, my x2, and my y2. So you go 6 minus positive 10 divided by negative 7 minus negative 7. I don't know what that is on the radio. That's crazy. Anyway, 6 minus 10 is minus 4. Negative 7 minus negative 7. You are going to add that together, and I'm going to get 0. This is different. Make sure you understand the difference between this, where it equals 0, and this, you cannot have a 0 on the denominator. No 0 in denominator. So that is going to be undefined. Okay? Make sure if the 0's in the numerator, it's a horizontal line. It's the slope is 0. The slope is 0. If the 0's in the denominator, the slope is undefined, and this is a vertical line. So that looks like this. Okay. My equation for this would be y equals negative 3. My equation this would be x equals negative 7. I can tell that because x is always 7, always negative 7. In this one, y is always negative 3. That's what makes it a horizontal line or a vertical line. All right, moving on. Here we go. Simplify these. What two numbers multiply to give me 192? I'm going to go and I'm going to actually look for 192 divided by x. I'm going to look for where my perfect squares are. I know 64 is a perfect square, so I've got 3 times 64. This just makes my life easier, because then I can say, okay, 64 is 8 times 8, and cross that out. Now I'm set. I can circle my 2 8s, and I've got my 3. 3 is a prime. I don't have to reduce that any further, and I get 8 square root of 3. This is my final answer. For 153, I do the same thing. I'm going to look. Y equals 153 divided by x. Go to my table. And I'm looking. I've got 1 and 53, 3 and 51. I'm going to look. Are there any other 9 and 17? 9 is a perfect square. 17. I would get the same answer if I use 3 and 51. This just makes it a little bit easier because I know 17 is prime, so I can square that. There's no two numbers other than 17 and 1 that multiply to give me 17. There's no two numbers that multiply to give me 3. But 9, I know 3 times 3, so my answer is 3 square root of 17. All right. What else? If I would have done, well, we'll just go on. If I 176, so I got 176 divided by x, go to my table, 4 and 44, 8 and 22, 11 and 16. Well, I know that 11 is prime and 16 is a perfect square, so right there, 11 and 16 looks like a good match because I've got a prime number. It's not always going to work out that way, it just has. And I get 4 times 4. I'm going to circle, and I get 4. I bring my circle out, and I leave my square in, and I get 4 square root of 11 is my answer. Here we go, 14 and 7. Well, looking at that, I can see that 7 goes into 14 evenly and 7 goes into 7. But if I wanted to go ahead and look at my 147, go to my table. Wow, not very many numbers multiply to give me 147. Here's 21 and 7. So let's just use that, 21 and 7. And if I multiply 21 out, I know it's 7 and 3. 7's prime, 3's prime, 7's prime. But I have 2 7s, so I can circle my 2 7s. Even though they're on opposite sides, I can still circle them. And I'm going to square my single because I don't have a match for my 3. And I pull out my 7 square root of 3. And there you have your answer. Now, the square root of 49, I'm going to look and see what numbers multiply to give me 49. Hopefully, you are seeing it now, but sometimes when you're in the midst of it, you don't see it. And I'm going to look and see what 2 numbers multiply to give me, and look, I've got 7 and 7. So the answer is literally 7. You circle your, and they come out, there's your answer. What about 64? Again, I don't really have to do this because I know what the square root of 64 is off the top of my head. But if I needed to, if I forgot, I can look, and look, I see it's 8 and 8 right there. 8 times 8 gives me 64. I don't have to do any more work. The answer is 8. 8 times 8 gives me 64. All right. Multiplying these. You're going to multiply your integers. 6 times 2 is 12. Now you add your exponents. Since you're multiplying, you're going to add your exponents. This is on, all of these laws of exponents are on your star chart. You add these exponents. M to the third, this would be m to the first. So you're going to add 3 plus 1 and get m to the fourth. Now we've got these negatives. Negative 3, n to the negative 2 is going to give me n to the negative 5. I'm going to go ahead and finish up. M to the 1 was m to the 3. Okay, what do I do with this mess? I cannot have negatives. No negative exponents. Ever. So what do I do with that? That does not mean that's a negative number. That means that this whole value goes to the denominator. So m to the fourth divided by m to the third, that bigger number is going to win. So we're going to subtract our exponents, and the one that is bigger is going to stay up there. So in this case, the 4 is bigger, so we get 12. The 4 is bigger. 4 minus 3 is 1. So I'm left with 12m. then this whole term goes to the denominator because of this negative exponent. This does not mean it's a negative number. It goes into the denominator as a positive number. And here's your answer. Okay. Then we've got your 3 times your 7 is 21. M to the 6th and m to the negative 1. I add my exponents and I get m to the 5th. N to the negative 4 and n to the 1 would give me n to the negative 3. Negative 4 plus positive 1 is negative 3. I cannot have a negative exponent. That goes into the denominator. So 21m to the 5th, just this term goes into the denominator and to the 3rd and becomes positive. The whole